Hello and welcome to part 2 of lesson number 6 in Unit 1 Linear Systems in our grade 10 academic math class. This is solving linear systems, substitution versus elimination. So in the first video we talked about in what situations you would choose substitution versus elimination. What we decided here looking at our first example was that cases where we have an isolated variable, meaning a variable that already has a coefficient of 1, those ones are a really good opportunity to use substitution. It's probably the most efficient way to go about solving it. However, if you don't have an isolated variable, if you have variables that have coefficients in front like we do in example 2 here, it doesn't make any sense for us to try to isolate a variable. We're going to end up with fractions. It just doesn't work out very nicely. So choosing elimination here, especially since these guys are already all lined up, requires a little manipulation, but overall it prevents you from using a lot of fractions, which again I think is really sort of a good thing. It hopefully creates fewer opportunities for errors. Let's move on to example number 3. So keeping that in mind, we have equation 1 and 2 here. We have, maybe I'll tidy that up a bit. We have equation 1 and 2. And what we notice right off the bat is we have a nicely isolated variable already. Here we have x plus 10y equals negative 9. That's a solitary x. What we can do is we can transpose plus 10y to the other side by subtracting 10y, and that will give us a new equation with an isolated variable. Pretty straightforward. Let's give it a go. So we are going to have then x equal to negative 9 minus 10y, and that's our new equation number 3. So we've isolated a variable. We are now going to substitute 3 into number 1. Obviously we can't substitute it into number 2 because that's the one we just built it from. So let's do some substitution here. We have 2, and instead of an x, I'm substituting in minus 9 minus 10y, and minus 5y equals 12. There we go. So that's our substitution step. Let's distribute that 2 into both of these terms and get to figuring out what y is equal to. So we have minus 18 minus 20y minus 5y equals 12. Let's gather together our like terms. Minus 18 minus 25y equals 12. Let's isolate our variable term by transposing negative 18 to the other side by adding 18 to both sides. That's going to give us negative 25y equals 30. And let's isolate y now by dividing both sides by the coefficient out front of y, which is negative 25. Y then will equal, okay, let's do a little reducing here. We don't want to have those numbers too big if we can help it. So let's divide both the numerator and the denominator by 5. And that's then going to give us 6. Actually, we'll make the whole thing sort of negative 6 over 5. Now that's not pretty, but that doesn't mean it's not right. It could very well be the right thing. Let's assume that it's the right one. And now we're going to go on by substituting y equals negative 6/5 into, and we can pick the first or the second one. I don't know that there's necessarily an advantage of one over the other. Maybe we'll just pick, it doesn't really matter, I guess. Let's just pick the first one, I guess. So we'll substitute into 1. So number 1 is 2x minus 5y. So 2x's minus 5, and here we have minus 6/5 in the place of y equals, and that is going to be equal to 12. Okay, now please recall that negative 5 is also negative 5 over 1, and we can do a little reducing here before we get to our final answers. So we've got both sides divided by negative 5. That's going to leave us with 1's in both the numerator and the denominator. Here we have 2x, and we have minus 5 times minus 6, or sorry, minus 1 times minus 6. That'll be a plus 6 equals 12. And we are going to transpose plus 6 to the other side by subtracting 6 from both sides. We have 2x's rather equal to 6 minus 12, or sorry, 12 minus 6 is 6. Divide both sides by 2 to isolate x. X is then equal to 3. And there we go. Let's get a solution. Therefore, the solution is, and let's write it down, we've got 3, and I think that was negative 6/5. Not pretty. Whoops, not pretty, but there we go. And that is our solution. So that's how we work this one. Let's shut this video down here. It's getting a little bit long, and then we'll work one more example in part 3. So we'll see you in part 3.